In this video, I want to look at the problem of finding the area between two curves. And this is really only part one. We are going to have another part in a separate video. What I want to do is I want to look at an area in the xy plane. So here's my xy plane. And I am going to have a function up here that I'm going to call y is equal to top of x. That's going to be my top function. It's the one that is on top. My bottom function is going to look something like this, and this will be y is equal to bottom of x. And I want to have an interval from a to b. And now I'm going to state the question. I want to find this area that I'm shading in that is between the two curves and over the interval from A to B. So our question is going to be, find the yellow area. And that is completely unreadable, so let me rewrite that. So our question is find the yellow area. Now, I don't want to reinvent the wheel, and so what I'm going to do is I'm going to actually draw some things that I already know about. If I highlight top in red, and I look at this region that I have bounded in red, and that I'm going to shade in red, this particular region, well, it's too big for my yellow region, but I do know what that region is. That red area is known to be the integral between a and b of my top function, and so I'm simply going to write it that way. Now, I want to also think about looking at the area that is trapped underneath the bottom curve and over the same interval. So I've highlighted its boundary in this blue color, and let's shade it in blue. So it's this kind of bluish purplish color. That blue area is known to be the integral between a and b of my bottom function. And now if I go back and I think really hard about that yellow area, which I am now coloring in yet again, that yellow area is the red area minus the blue area. So let's see, let me get my color right. The yellow area is clearly the red area minus the blue area. But that means I can find it in terms of integrals. So the answer to my question, that yellow area, is going to be the integral between a and b of my top function minus the integral between a and b of my bottom function. And so what I now have is a nice formula, because I can rewrite this as the yellow area is going to be equal to the integral between a and b of the top function minus the bottom function based on our properties of definite integrals. And so we have this basic formula that says that the area trapped between top and bottom is going to be the integral between a and b of top minus bottom. And that is a formula that you should have in your notes. So stop the video and get that written in your notes if you don't already have it. Now, the next thing that I want to do is I want to think about a comment that the authors put in the text after their first worked example. the comment is about, does this formula always work? What if the top function or the bottom function doesn't happen to be above the x-axis? So what I want to do is I want to look at this particular situation. What if we have this? And here I'm going to draw my chunk of area that has a top function that is still nice and above the x-axis, but the bottom function is below the x-axis. So the bottom function is down here. And here is A, and here is B. And the area that I want to find this time is all of this area. And I want it as a genuine, bona fide, ordinary, positive area. So again, I still want to find the yellow area. Well, what I want to do is very much the same thing that I did before. I'm going to, first of all, think about this area, which I am highlighting the boundary in red. This area that I've highlighted in red, which I will now shade in red, that area is known to be the definite integral that is from A to B of top. So my red area is the integral from A to B of top of x dx. Now I'm going to draw a blue area. And this blue area lies underneath the x-axis. So I happen to know, and let's shade that blue area in as well. So here's the blue area. Now I know that the blue area is, I need to think about it in two different ways. The blue area needs to be a positive area if I'm trying to find the yellow area. But I also know that if I integrate from A to B of my bottom function, that is going to be a negative area, and it is going to be exactly -1 times the blue area. So I'm going to write this as minus the blue area. So what I notice now is this. My yellow area, which I want to go back and remind you of what it looks like in terms of shading. The yellow area is both of those chunks. The yellow area is clearly going to be equal to the red area plus the blue area. But this time when I look at my integrals, what I'm going to have is that the yellow area is going to be, well, the red area is the integral between A and B of my top function. And then I want to add the blue area. Now the blue area is minus the integral of the bottom function. What I want to do is I want to look at this particular equation. Minus the blue area is equal to that integral, and so what I can say is the blue area is going to be minus the integral from A to B of the bottom function. That again is one of our definite integral properties that if you want to be looking at area that is under the x-axis, it's going to be a minus sign, and so we can multiply that equation by -1. And so we're going to have minus the integral from A to B of bottom dx. Well, let's clean this particular formula up, and when we do, we find out that our yellow area is going to be Let's see, the integrals are from a to b, both of them, so we can simplify this to the integral from a to b of the top function minus, because of this minus sign right here, the bottom function. And then I will want to integrate that with respect to x. It is the same formula. Well, the last thing that I want to do is look at the third case that we might have. Our third case is this scenario. So what if we want to find this area? Here I'm going to have both my top function and my bottom function below the x-axis. And the area that I want to find as positive area is still going to be this chunk of area. So I want to find that yellow area as a positive area. So find that yellow area as positive area because it's just a region in the plane. Well, I'm going to continue doing the same thing that I did before. We will highlight a chunk of red area that I know is connected to the integral of the top function. This red area as positive area is going to be minus the integral between a and b of my top function dx, because minus the red area is equal to the integral of top dx, because top is underneath the x-axis. I'm going to do the same thing with the blue area and bottom function. So there is a nice blue highlighted border, and let's color in that blue area. And this blue area as positive area is going to have to be minus the integral between a and b of bottom of x dx, because bottom is below the x-axis. In other words, the integral between a and b of bottom of x dx is actually a negative area. And since I want positive area, I have to throw in that minus sign. Well, now again, what we're going to do is exactly the same thing that we've done before. Our yellow area can be thought of as follows. Oops, let me get my color right. My yellow area this time can be thought of as the blue area which is here. The blue area is everything minus the red area, because the red area is this chunk here. And when I take the blue area and I subtract off that red area, what I am left with is indeed the yellow area that I am trying to find. So now it's a matter of plugging in the integrals and doing some simplifying. So my yellow area is going to be, well, the blue area as a positive area is this thing here. It's got a minus sign in front of the integral. So I am going to very carefully put that in. It is minus the integral between a and b of bottom dx. And then I've got a minus sign, And now I have the red area, and I want to remind you that the red area is also an integral with a minus sign in front of it. And so when I plug in the formula for the red area, I have minus the integral between a and b of top dx. Now, we need to do a little bit of simplification. And when we do, we're going to find out that our yellow area is going to be, well, let's see, I've got minus the integral from a to b of bottom of x dx. And now I've got a minus, so that's a minus, it turns out to be a plus. The integral of top dx. Well, I can rewrite that as the yellow area is the integral from a to b of top minus the integral of the bottom function. And lo and behold, what we have is exactly the same formula that we had in the other two cases. We're always going to want to look at the top function and subtract off the bottom function. So what I want to do is I want to end this video with, we have a basic formula. Our basic formula for areas that have what I call top-bottom areas, for top-bottom areas, is that the area is always going to be a definite integral from a to b of the top function minus the bottom function. Write that formula down in your notes.